Yes. So being the last topic, this is very tough to manage the time of. Let me see what best I can do to stick to the time I have to close it. So nowadays you see the modern application development landscape, especially with the advent of cloud computing, has changed drastically. Now developers are required to work on the projects or the products or the applications that are deployed geographically and highly available applications, right? And so much of other stuff that is pertaining to cloud computing has to be taken care of. So we need to have a separate strategy or a design pattern as such to come up to cope up with this kind of change. So 12-factor applications is setting a tone as a baseline to come up with this. Before deep diving in, here are my coordinates where you can reach out to me. So Adam begins with the co-founder of Heroku Cloud, who and his team came up with 12-factor applications to set a tone as a baseline for developing cloud native applications. Roughly around 2011, 2012 early times. This has shown at least a guidelines where people started implementing the code base or even or adhering to the characteristics that are being mentioned over here. Now, before deep diving right each and every topic, so here is the high level list. Couple of factors target on the code base itself. Couple of factors target on or the talks about how the code base is being transformed to the deployment. Either you talk DevOps, continuous integration, continuous delivery, whatever the value chains, it talks about that. And a couple of patterns talks about the runtime environment for these applications to be facilitated. And finally, we have administration tasks as well to be covered. So without further delay, let me get into the first factor, that is code base. So the basic criteria or the notion here is that every code base has to be tracked into the version control system. This is a mandate here. Now, there could be multiple versions that are subjected for a period of time with whatever the process or the life cycle that we follow with continuous delivery cycle or whatever it is. But they made it as very mandatory to come up with that. And one more aspect is code repository. One code repository for one application, they tied it. It means it is a thumb rule to have one application per code repository. So don't go with multiple applications in a code repository, or don't cascade distribute your code base across multiple repositories. And it has to have one root commit and proceed further. Now, let us take a small assumption or hypothetical case where you have a production scenario and non-production environment, two environments. And you have two different branches as well, production branch, non-production branch. And as these guys are talking about one code repository for one application, to deal with multiple environments with one code base, how to handle this is being addressed here through multiple deploys.
But is it good to have a single code base for multiple environment, or
single code base in a single repository target for multiple environments? That's what I'm going to explain now. Okay. So in a typical cycle, right, where developers are working on the feature branches respectively, and the moment one particular feature is being implemented, they commit to the local repo, and finally they push it to the code repository. The branch will be pushed to the code review. Once the code is reviewed and accepted, right, it will be pushed to the non-prod branch. Okay, the difference between prod and non-prod is only lifting of the quality gates. Otherwise, the rest of the lifecycle policies or the pipelines doesn't talk about production at all. Only non-production environments talks. Now the code goes to the production branch, non-production branch, and it will get built and it gets deployed to the non-production environment. So as part of the life cycle of this particular application, at a certain point in time it has to be put back to production, rolled out to the production. That is where the non-production branch will do the commit back to the production branch, the clone back the entire stuff out there. And this is where it will get built over there, the code base will be built over there and pushed to the production branch. This is how we cover multiple deploys of the same code base in a single repository, but multiple branches are doing.
How to do the hotfix? Means if there is any that occurred in the production code. So
okay, I will talk about when I talk about releases, I talk about this. Okay, one thing as part of the best practices, they say avoid staging deploys, so that you don't accumulate multiple features in a particular branch, deployment branch at any given point in time. So what it happens is, over a period of time, if some of the developer will commit the code base to the production branch, and suddenly you see the resource crunch over there. In the other environments, the number of resources that is being used, and the production environment, the number of resources will be used, there will be a difference, and you get into a buggy environment. So again, identifying through the quality gates where exactly is the bug, where exactly it is introduced, it will get into a lot of quality lifecycle to correct that. So as a best practice, they say avoid staging deploys. And one of the factors that talks very detailed about it, how the dev and prod clarity should be. Right. So in summary, complete code base is tracked in a VCS, and the repo contains single application with a common root commit, and multiple environments are handled through multiple deploys. This is pretty straightforward. And the anti-patterns is different code bases for a particular application is an anti-pattern. Never get into that as a best practice. Or one code base holding multiple applications. This is also not being suggested. These two are completely avoided when you are targeting 12-factor application development. The second one is dependencies. Very usual fashion, right? I have taken Java as an example here. Typically when we try to develop the application and deploy it, we try to keep the dependencies in terms of the libraries, everything put together in a particular target environment. For example, say application Java's application server, I'm trying to deploy it, application J. It has got dependencies of 10 libraries or 10 Java files. And there are specific to a particular operating system and specific platform type, say 32-bit or 64-bit, whatever it is. Right. And sometimes I get used to reuse the same libraries across multiple applications. What happens, there is the kind of issue that we face, right, when we are trying to port the same application to a different container, and there could be issue with the vendor lock-in libraries. The second issue is if there is a little bit of catch upgrade to the operating system, so the cascading of the issues, it goes up to the libraries level, and my application will get detached completely. And probably I will upgrade everything and come back. And I'm trying to reuse the same application, the library by multiple applications at any point in time. And one of the application requires, or app 4 requires an updated version of this Java file. And suddenly what happens is, the rest of the applications will be broken. So these dependencies is a common problem. And 12-factor applications suggest a different approach, how to handle this. Isolate the dependencies. Take a separate runtime environment for every application. This is where we oversee the fitment of microservices or nanoservices, everything that is coming out. Right?
Yeah.
So isolate the dependencies. Let the application, for example, the app 1 and 2 are using version 1.0, app 3 is using 1.1, 1.2 here. It doesn't matter, let them live in their own life. And this is called self-contained, self-sufficient enough. the advantage what we are getting is portability here. If we don't have, or the application doesn't have any dependency on the underlying platforms, I can lift and shift to any kind of environment, irrespective.
But will it not increase the maintainability of the application?
So everything is a cost. Obviously, microservices is not simple, right? Again, the monolithic development, I'm used to that for the ages, decades. Now suddenly the shift is there. Now to live up to that, what exactly I need to do? Again, decomposing, the design is different, the architecture is different, number of components of the layers are increased, right? And the endpoints that I need to stitch together, I need to be aware of the entire concepts, right?
Yeah.
So the price is there across. So one thing is the portability that I am able to do it, even on-prem or cloud, I can easily port it, right? And especially when I am trying to keep these dependencies into mind, I record all these dependencies into some manifest file, a deployment, a descriptive kind of manifest files. So nowadays, majority of the languages is providing some sort of way of covering these dependencies into the manifest. The Java, Node, Ruby, Python, everybody is providing it. So need to leverage that respective thing, how to externalize these dependencies, not to tightly bound with the environment. So the anti-pattern here is dependency hell. Look into this Wikipedia, a lot of description is available. Okay, too many dependencies if you try to see. It means overwhelming the functionality of a microservice leads to the requirement of multiple libraries. Too many of them. Long chain of dependencies, one dependency calling the other dependency and all, and conflicting, circular. So many of the patterns, again, anti-patterns are there to take care of that. This is where people look for alternative solutions where let the container be provided by the service provider, like a cloud provider. I just develop my application and deploy it over there. Let the Docker container, whatever the container providers are giving me, or even function as a service, what Veers mentioned, right? Let the underlying work be taken care of and the operating system on The third factor is config. Store configuration values in the environment, especially when I'm trying to deal with any external systems apart from my particular microservice or an application. Anything that is like a third party to me, including the database. So how to deal with that? Should I hardcode some values? Load factor says no. It has to be induced through environment variables or through service callouts. You need to fetch the information and application has to dynamically plumb to those resources in flight and try to behave. So what you are going to achieve here is, my code base is common across multiple environments. I don't need to refactor my code or the build for a target environment. The same code base, same build I can carry forward to multiple environments. And what I need to take care is, in the target environment, these environment variables, appropriate environment variables have to be in use with that. And for example, look for Drop Wizard and Spring Boot kind of frameworks, right? They do bootstrapping of these environment variables whenever they start the application. Okay, this is all being provided by a lot of frameworks. So if you can't reinvent the wheel starting from the scratch, leverage the appropriate framework and do it, including even the Node.js libraries are there. Look at bootstrap and introduce them to the environment variables whenever these applications come out. Okay. So, in nutshell, the hard querying of the configuration data has to be come out. It has to be free, the code base has to be free from your DB credentials, external service credentials, or the URLs of that external service URLs, right? Even the proxy values. Sometimes we see my DevOps solution where my deploy solution is trying to put it into some Docker container or Docker runtime over there. And these two services are being behind the firewall and behind the proxies or something. So my deployer component like a Hassan or a Jenny, right, I need to induce my HTTP proxy values to the deployer in order to connect over there. So these are all has to be provided by the runtime, and what I just need to give is the environment variables. Okay. The three approaches that they have mentioned in the 4-factor apps: get the data from external service or the environment variables or any kind of custom services. Okay. In summary, one of the examples how it is being treated at Oracle, right? So what we provided. Application and configuration, two things. Configuration is specific to the target environment. So what I give in terms of a deployment.json file, all the environment variables, service bindings, everything. For example, I am deploying a Java application, I need MySQL Cloud Service. So a service name or the port number or a particular connector, the JDBC connector URLs, every data will be provided by the runtime. Right? So the advantage over here is the moment I change my code base, my build from one environment to the other environment, even if I want to manually tweak the database, I just change the binding and restart the binding. I don't need to bounce my server of the database or bounce the server of my immediate target. Nothing. Only the binding restart needs to be done. And similarly, from an application point of view, two things I'm giving it. One, application archive file, either zip file or ER file, WAR file, whatever it is, and the manifest.json file, which covers all my dependencies together. So one is application archive, which has the dependencies, and another one is environment specific configurations. These two are very much essential to one. Okay. Right. Anti-pattern. Be careful of OMDO. Here. Ensure every time you deploy to the target environment, your environment values are refreshed. Otherwise, you'll be trying to execute the pre-production environment variables in the production. So the bootstrapping process has to be perfect over there in terms of loading the environment variables. And here, one thing is, don't run the configuration management inside your container images. So typically, a lot of misconception, right? If there are a proxy values or something that is specific to the organization, I try to induce them to the image itself, my Docker image itself, and custom image I will build it and send it to them. If something happens, if I need to take a generic image, it will bounce. Okay? Keep that immutability matters a lot here. And the fourth is backing services. For example, as part of your application, right, which has a lot of functions in it, each function is trying to invoke an internal service or an external service. It could be a database, it could be a cloud service, a messaging service, or a file system, or like an object storage. Somehow you need to ensure your application function is treating all of them as if they are accessed by a network, a local services. How to fetch my object storage Amazon S3? How to fetch it? So the appropriate URL information or authentication information that is required by your function has to be made available through the environment variables again as part of the configuration data. So backend services will play a nice role if you can detach that or maintain that agility over there. Okay. Swapping out of the services in each environment will become very easy if you can maintain that. Okay, some people say today I'm keeping Nginx as a web server. Tomorrow I wanted to swap it with Apache HTTP server. I just go and make the URL substituted over there. If I can make my environment variable available, the endpoint URL, my application takes only the URL as an input and makes the appropriate HTTP connection. Yeah.
Speaking about environment variables, a function will be within the container, and more specific we should not put inside the container. So where the environment
Okay. I am talking about the bootstrapping of the environment variables within the image. Take a plain Windows image or Linux image, right? and you deploy the application, start the application. The moment it starts, right, an application server and appropriate environment variables will be set, then the application will start on top of that. But some people say, create a custom Docker image which has all these configurations set and deploy the application and start with that custom image. That matters. You should not do that. Yeah.
The previous one, can you go to the previous slide? When you say treat external systems as local one, I find a lot of my developers, they don't do the network checking, they don't do the exception checking, they have to do it, right? So I'll be giving a wrong message here. I'm not very sure. That's why I'm asking, because most of my developers, when it's external, there's a network involved. Network can be up, network can be down, and the application has to handle it. Some of them don't handle it. They assume everything is local. They have put everything local, everything works. They put on a network and boom, everything breaks. And it's as simple as they have not done exception handling. So, I'm not sure, are you addressing that?
So, the moment we are talking about cloud native application development, right? The target platforms are completely cloud enabled platforms, either is a private cloud or public cloud. And networking based lookups are very much essential everywhere. Treat storage is a network, treat even DNS connected over the network, and any kind of backup solutions over the network. Similarly, my microservices. I don't directly call microservice, right? I try to keep an abstraction layer like a messaging layer or a gateway, API gateway, something. Everything is like a HTTP lookups, networking calls. So it has become like a de facto standard in this particular cloud native world. And that is where my frameworks are taking care of this. Why in microservices I come up with the high availability pattern. If the function is not being made available after a couple of retries, it doesn't cascade the problem to other services. Why these frameworks have come out there? Just to pacify this. But developer is not writing any code. No cache, try and cache. He's not writing that.
Yeah, means if you fail fast.
Fail fast.
You should not propagate the things.
You should try to treat everything as a remote system. Yes.
Okay.
Consider everything as a backing service which comes from a remote, even though it's local, so that you just modify your configuration and
so the nomenclature that is mentioned in the code factor next slide also, right? They say treat external services or other internal services also local ones only. The way JDBC lookup I do, right? Context I take, JNDA context I take it. But my JDBC server, my database server is running on a different machine altogether. How am I making that JDBC context? I give the IP address and the port number, service ID, service name, everything. Construct JDBC URL and try to create a connection. But I don't see a network timeout exception that is mentioned out there in my code block. I never see that. It means I am considering my database server as if it is a local resource. The context I am establishing out there. Okay, I don't delve into too much of the underlying layers. Okay, even we have been doing since long time, but we never assume that yes, network is not being mentioned over here. But explicitly, if I am making a HTTP connection object using a net API or something, right? I try to see multiple retries, remote host not available, host not reachable exception, so many things. But when it comes to this word, I never handle it. These are all being offloaded to the framework vendors, whoever is providing. Right?
The framework vendor is not offering.
They have to, otherwise they are not a proper vendor. They have to, this is their headache.
No, actually, okay. The reason why I say this, I built something like the Wells Fargo one, where they stitch all applications. I stitch applications. When I stitch applications, they are not frameworks, they are all SaaS applications. They don't really take care of it, right? So I have to actually take care of, orchestrating all of them and offering a solution. And my customer, if it breaks, I can't go to my customer and say that someone didn't provide it. He's going to beat me out, right? Or it's not just going to walk away and I'm going to be bankrupt.
But the architecture is not stateful over there. In microservices, Java are completely stateless.
No, the scenario I am talking about is also stateless, but someone goes down, right? And when it goes down, you have to understand it has gone down and you have to give the right message back to the people, and you can't assume that the other service will always be up and available like a local service. That's all I'm saying. Because when you think it's a remote service, you know it may go down anytime. When you think it's a local service, you make an assumption that it will be available always.
So that is where the high availability of the service matters. The serverless architecture, what he mentioned, right, it never goes down. And some people develop at a hackathon and rolled out, never went down. High availability is being taken care by the vendor, the framework vendor, Azure.
I think the point is trying to communicate is, you got to, no matter how robust the app is,
Correct.
and services, you have to put a little bit of validation here. At least
We do that.
exception handling. And
We do that.
Yeah.
So typically, okay, yeah, okay. I have a point over there in the
Developers
comments.
are not writing exception handling, they are just saying the
No.
cloud infrastructure framework will handle.
No.
And my systems are breaking, and I am an architect who, when it bleeds I am on the road, when the rubber hits the road, right? And when it hits the road, this answer I am getting from developers, and that's the reason why I am saying this forum too.
And it
So
should be the
there is a concept, there is one more factor called disposability. During the start of that my service, I need to ensure all my resources are available over there. During the shutdown of that, gracefully I need to close the connections and shut it down. During the crash scenarios also how to handle that. It has been addressed as one of the factors for that. Okay. And one more thing is, especially from the transaction-oriented systems, one of the backend service that they use is either cache service or very small end database services to hold the context information into that. But they never hardcode into the heap of that. One of the anti-patterns here is no local disk. Always connect to network attached services using connection information from the environment. Never start a service along with your microservice itself. Means plumbing the second service with a microservice and starting on a single container. Don't do that. Okay, dispose that into a second one and start over there and access that over the network. The fifth factor is build, release, run. This is where we talk about continuous integration and continuous delivery, right? Whatever the build that, whatever the code base that we give, we develop and push it to the repository, probably a distributed repository like Git. Now, the initial stage that would be the build to getting to the production. This is where my config data and my source code both are being lumped together, make a deployable artifact and push it to my deploy phase. So probably continuous integration I'll start and slowly get into continuous delivery piece. But my build is triggered either manually or through a code review process. Once the code review is completed or it is scheduled timing, I need to file the build, and my release system here will look for in what target environment I am trying to deploy it, whether it is pre-prod or staging environment, any other environments. And the appropriate config data has to be taken and embedded into that, and my release system will deploy to the target runtime. So the target runtime, take an example of a Google Java file. I'm just starting Google Java file on a Docker container. Now that Java file has to first induce these config variables into my system environment variables, then start my JD container or a Tomcat container, whatever it is, then start my application. This is the process it has to take, carry forward. If there is a code change, build and release has to happen together. So every release is being time-stamped or the version number, some nomenclature, I keep it and follow that. If there is only a configuration change for a various deploy to a target environment, a different environment, then I don't need to get into build. I just take the same build, plug the config variable and put it into release and push it to the deploy. Okay? Running straightforward after that. So in summary, the build release run. In the build process, I'm taking the code from the code repository and creating a deployable artifact. Okay. And in the release process, my release application will collect the config data and the deployable artifact both, lump them together and give it to the appropriate runtime. And running is just launching a particular program and a command in a Docker environment. Here is that even this topic is being covered multiple times today. Okay, install and deploy, build immutable images, then run those images. Right. The sixth one is processes. Okay. This is a very interesting topic here. When it comes to the application management, my system administrator look at processes. This guy sees my entire application server as one process. How many applications you deployed? But whereas my developer look at 10 applications are deployed. There is a different understanding level from application management point of view. So to sort out that, right, we introduced another role called application administrator. This guy sees many applications, what developer wanted. So in 12-factor application methodology, we don't talk about monolith applications again, right? Like microservices kind of applications. This kind of development, if you can decompose your entire application into multiple processes, they don't call it as microservices as such, multiple processes. Then system administrator will look at multiple processes. Then how the process should be? It means even an application, if you can run from a command line instead of deploying this application into a JBoss container, if you can run that from a command line, then my system administrator will look at that as a process. This is a little bit of a shift. So some people call it as a microservice or nanoservice, whatever a service-oriented approach, whether it is a function or a service altogether, not a problem. So when we are dealing with this kind of process development, right, we have to be very much cautious about memory usage. The memory usage by a process has to be a single threaded. Means you have to attach that synchronizer clock. Okay. Typically developers won't deal with that. My framework vendors itself for writing the code is completely within life cycle methods into that. Okay. And the memory utilization has to be very sharp layer. If you want to persist some data, then put that into a cache solution. That is better. So why? Because my process can be killed by abruptly because of any crash or something. Then when my process restarts back, this is where cloud vendors come up with higher availability, right? It will restart on the same RAID server or same server, if not on somewhere else. If the cache is a distributed cache, my service can reinstate it back from whatever context data it is already persisted into a cache. If you want to hold the data for a certain duration, probably then leverage database instead of cache. So processes are typically stateless, no sharing anything, and data that needs to be persisted must be stored in a separate backend service, which is a database oriented service, treated as a stateful service. But there is no concept of sticky sessions here. We should be away from that completely. Anti-pattern, if I want to have a clustering of JBoss or Tomcat or a WebLogic something, what to do? Don't try to use the storage file system that you have locally over there. You have to get into NFS or leverage something which can be accessed over network, and these data should be made available in the environment available setting. Right? Pardon? Absolutely. Internal mounted, I mean to say, it is mounted. It is an external one, but it is treated like an internal one. I just posted. The other factor, the seventh one is port binding. Port binding. Now, my application is deployed already. Now, application has to get the request and give the responses back. There should be a communication channel established. Now, take a case of a database runtimes. If I am running my Tomcat server 8084, what if multiple Tomcats are running on multiple containers over there? Now, the code or where the listener has to be made available, where the requests and responses are coming for a particular communication protocol, right? It has to be binded to non-standard code on the host, not on the guest. I mean, non-standard is pretty much clear. So, do the developers need to be clear about these communication protocols? Typically not, right? Again, it goes to the framework vendors, how it has to be implemented. So some of the runtimes, if you, anybody worked on Apache, Beanstalk, or Oracle's application container cloud services, the moment you deploy your application, automatically a port, a non-standard port will be allocated to that application if it wants to communicate over that, to the external world. And dynamically you need to get that port number. And that port number you can't hard code in your machine, in your code base. It will be accessed through some environment variable, and you listen on that. When you are doing a local testing or local development time, you introduce that into environment variable, certain port number, and finish your coding and deploy it. Okay. This is how a routing technology is being introduced by the runtime vendors directly to communicate between application to application. And it matters or it doesn't matter, even if it is a polyglot application development. Because everybody treats exposing a HTTP service to the external world or a port binding. Right? In summary, the app exposes a HTTP as a service by binding to a port, and implemented by using dependency injection technologies, by adding a web server library to your application artifacts that is getting deployed. This is where we are calling it as a bloated jar file or a Uber jar file, like Jetty for Java, Tomcat, or even or lightweight Java servers. Everything people are providing it, right? Now, anti-pattern. Never hardcode that in your configuration. Give an environment variable. Try to get that. Concurrency. Any application that we try to deploy, because we recommend capacity planning is very important. How do we do that? Or how do we address it typically in a legacy applications? I have an application, sudden spike has come. Probably I will spin up more instances of the application. Means some sort of a horizontal scaling. Or if it is not sufficient, something like a database technology, right? We prefer to bloat it up, vertical scaling. In worst case, what we do, we will cater to the other machine or other VM and spin up more instances and try to come up with that. But in case of microservices kind of technology, where the processes is one of the factors that we adopt, we can't look for the vertical scalability. Horizontal scalability only matters. Okay? Because of various reasons that I'm going to talk about startup times, startup times and stopping times, everything, etc. But horizontal scalability is being proven. Even if you increase the taxation on that load, right? If you spin out, my load balancer can cascade distribute the load base. Now, 9 one is the disposability. This is where I want to have a quicker startup time, for my applications. One thing is from a security standpoint, as a best practice, a lot of people say, right? If any process is short-lived, means it is starting serving the request, and probably after a predefined interval it will get hibernated. So the risk of compromisation is very, very low over there. So this is one of the aspects. And the scalability wise, it is proven horizontal scalability will work better. And fault tolerance. If something goes wrong, my system can go for crash. My service can go for crash. It gets down. And if I leverage my appropriate DB cache or a normal caching technology to persist my context over there, my service can be killed abruptly and it can start back with the context established. So it matters how quickly I can roll out my particular process. It should be in seconds or sub-seconds. It should not be minutes. That's why we leverage, even for database also, the small end of containers like MySQL or NoSQL or something, not Oracle database or DB2, bloated databases. So anti-pattern, above that. Ensure that your process is not holding any data in memory of or the heap of the process. If you hold that, in case of a kill or a system gets crashed, there is a chance of losing certain transaction data out there. Dev prod parity. Okay. As we said, if you are staging multiple features without testing, further testing and giving it to the release, slowly over a period of time, right, a new developer comes in, he'll clone the entire repository and probably he'll modify his code base and push it. And probably it might go to production at some point in time. And we see the difference over there. In terms of a buggy code might come out there and probably will come back and rectify that code base and push it back. Unnecessary versions will be released over there. So there are three topics that have been identified here. One is make the time graph very small. A developer may write the code and have it deployed in a few minutes away or a few hours away. Keep that time gap very low. Then quickly they can take a call if something goes wrong, pivot it. If you stage it for 15 days or 30 days, right, multiple builds will happen and we don't know where exactly which developer has been, in what context he committed that buggy code. And another one is to make the personal gap small. Developers who wrote that code has to have a visibility that he is deploying and monitoring that particular application over there. Don't rely completely onto the ops guys. Where one of the cultural shift of the DevOps, understand that. And make the tools gap small. So if you are using Nginx in a non-production environment, try to use same Nginx in production environment. Don't try to go for Apache HTTP server or something. So these three things are being addressed, are being mentioned as part of this particular factor to keep that dev prod parity. And logs, it is very much important. And it is advised not to use any log files or persist it to the local file system. Always use stdout as a streams. Every process that is running, or process or an application that is running, has to emit the log content to std out as a event streams. And every process has to commit to the same event stream so that I can use a log aggregator, something like a help for my reporting or archival or further processing, etc. It is being made as mandatory, and it's been proven in many cases that how important it is. Okay, so never attempt to write it locally. Instead, each running process writes it to stdout completely. So anti-pattern, don't maintain any random log files across the board.
Why local log files?
It is being advised over there because in microservices jargon, right, you are getting into hundreds of services, probably for a large enterprise. And trying to understand a root cause at a particular point in time will become a difficult. So if you are emitting to event streams, right, a timestamp will be there and a source who emitted that will be there. I will sort out everything as per that, and I see a pattern, trending pattern. It will be easy for me to analyze. Otherwise, I have to collate all the log files and give it to some systems like to load it manually and try to see it. But in real-time monitoring, I can see it if I edit it over there. Otherwise, even a few vendors, right, even cloud vendors, you have to click a button explicitly to generate a log for the last 5 minutes and 10 minutes. And they'll take a 1 minute time to collate everything and put it into Amazon S3 bucket and you download it from there. So it's not the case if you want a real-time monitoring and trying to see it. The last pattern is admin process. So administration tasks are very important, especially when your process is starting up or application is starting up. Probably I need to fill certain predefined data into my cache, or periodically I wanted to wipe out the cache data, or something has to be made available at the startup time. So how do you take care of these lifecycle activities for a particular application through administration tasks? And in legacy applications, right, we try to keep these are all like a programs into bad jobs and put it into my code base itself. Like as and when it is required, I just move the class file or like a batch file, trigger it, and it will clean up and come back. But here it is advised that you keep this admin task completely separate and deploy it in an identical environment, the way your application or a process is running. Don't try to create a separate image altogether for admin tasks. You can keep it over there. And there are a lot of recommendation that is made available again. And when you are deploying your application, your admin code base also has to go. You consider admin code base itself as a 12-factor code base again. So you are typically dealing with two different code bases here. Okay? Keep that identical environment. Don't go for custom container for tasks, for the admin tasks. And there are people again innovated more or try to delve more what is exactly missing. And there is a nice book Kevin Hoffman has written, Behind the 12-Factor Apps, that talks about API first approach. So how to define the process first. Is it a top-down, bottom-up? In service-oriented architecture, we came up with multiple ways of design. Right? But when it comes to the process, legacy modernization of a monolith to a processes, how to deal with that? Square has come up with one suggestion of the API first. And second one is telemetry. Application performance monitoring will help me to see the pattern of during the workload time, how my process is behaving it. When workload goes down, how it is gracefully shutting down, scale up and scale down, both of them. And domain-specific telemetry and health and system logs. And finally, security thing is not being addressed in 12 factors. It is being given to the vendors how to deal with them. So we covered all three aspects in very detailed in the book. Really very good. Summary, pretty straightforward. What I'm doing is I'm achieving the portability, very importantly. Scalability I addressed with this. Maintainability will come very easy. And other aspects of marketing stuff, really not going to get into that. Right? Any questions? Probably this is very actually covered this in serverless.com as new serverless summit that is coming up. When we're trying to come up with a booth over there in this particular event as well. You can meet over there. Any questions?
I mean, this 12-factor app, pattern or whatever you call it, do you think, does it apply to building software of all sizes? I think unless you have crossed certain threshold, you don't, because it's kind of bloating, right? And it,
so, cloud native web application development, a category mentioned in the first slide. If you talk about integration cases, it doesn't applicable. If you talk about big data applications, doesn't apply over there. Cloud native web application developments, completely. We can't deal with any complex systems with that.
I mean, if you're building a in-house application or something, then kind of it's a blueprint, right?
Okay, at on-premise applications, probably if you are looking at a container-based approach to roll out, this is completely applicable because portability matters. Tomorrow you can move all these containers to cloud if you follow the same standard. Keep that in mind, even API first. I can leverage that at on-prem or big cloud, it doesn't matter, I can take it up. No questions? Thank you very much for your time.